And it was surprising, really, that any topic or any course on system analysis and design would start off with the idea of acquiring an information system first. And let's start off with the idea that when you have an information system, you're actually trying to look at a problem. Okay, obviously, systems, be it a manufacturing system or even an information system, they are there because you like to accomplish something. There is an objective that you want to do, right? And more often than not, you are looking at a problem and addressing that problem. So when we look at information systems, uh, it should always be uh, a habit, if you may, that we start with a problem first. So we don't just go about implementing information systems without understanding what that information system is supposed to do, right? And it would be good to articulate the problem first before you actually go ahead and start your information system implementation. So a problem, you can look at it both ways. The more common way of looking at a problem is that it's a waste. Okay, it's a problem. Right now in our parlance, we consider problem as something that's inconvenient, right? Uh, but we can also look at the problem as an opportunity, in the sense that when we try to recall the parlance problem back in the old days when we solve math problems, right? Uh, they're not really bad when we try to solve math problems. Some of us might be inclined to tackle problems, right? So it's not really inconvenient for some of us. But whenever we take a look at problem in today's world in business, more often than not, maybe we say 8 out of 10 or 9 out of 10, problem equals waste. It's an inconvenience. It's something costly. It's something negative. Okay, so we always look at a problem, and that is what any information system should be addressing. It should address a problem. Now, when we look at waste, so what are the different types of wastes? Okay, so for those of you who are familiar with lean manufacturing, so these are the different types or different classes of wastes. So a waste can be a defect. Okay, so something is missing. A waste can be excess processing. So in a typical process, there is maybe one or two additional steps that are not really needed. Okay, or it can be an overproduction. You create additional products, maybe additional components to the products that won't be used, or you produce an excess of the product, which is inventory. So if you can see it in the fifth bullet point, so overproduction, inventory, they're both excesses. Waiting. So in a typical process, if you're not doing something and you're waiting for something, right? I mean, you're sitting there, you're not doing anything because you are dependent on the output of something else. Okay, and in the interim you're not doing anything else, then that could be considered as a waste. Okay, transportation. So moving from one place to another, because it also consumes time, that's also or can be considered as waste. Motion, excess movement. Okay, and the eighth waste, which is not considered as waste in the manufacturing sense, but it should be considered as waste. The idea of non-utilized talent. So if you have excess people, okay, they're there, they're not doing anything. They are either underutilized or not utilized at all. Okay, they're wastes. And especially if you're in a company, you also spend for them, right? You pay for their salaries and all that. And if they're not going to be productive for the company, for the organization, then they can be considered as wastes. Now, what about opportunities? So opportunities can take the form of market trends. So maybe there's new demand, okay, or there's a new market category. that slowly emerged, okay, from some technological advancement or evolution. An opportunity can be something in the political landscape, okay, a transition, a change of leaders, okay, or maybe something happened, in terms of agreements or alliances among parties. Okay, those could be considered as opportunities, or even social cultural shifts. Okay, people's way of doing things, their habits, their customs. Okay? If things weren't like that maybe 10 years ago or 15 years ago, okay, they can also be considered opportunities. Now, if you look at it, wastes can be something considered as internal to you or to your company. Opportunities can be viewed as something external to the company. So, and they're not exactly diametrically opposed to one another, right? They could overlap. They could work hand in hand, or but they can also be competing with one another. So when we look at a problem, okay, we take a look at both the internal side, which takes care of the waste. We take a look at the external side, which talks about the opportunities. And then based on these two things, you can come up with your own strategy and policies and objectives and targets. And from that idea, that's when information systems come into being. Okay, they come into existence. Now, it's possible that your IS, your information systems, can be based on just simply waste, addressing waste. Maybe you just want to be more efficient in a certain process. Or an information system can be based to address, let's say, a certain market shift, something external, an opportunity, right? Or it can be both. Okay, it can be both addressing a waste and addressing an opportunity. Okay, but nevertheless, when you have an information system, it will always have that idea that it's supposed to address a problem. And the articulation of the problem is either an internal matter, maybe waste, or an external matter, which is an opportunity. Okay, so that's the very first fundamental idea when you think of coming up with a system. There has to be a problem that you want to solve. I mean, you don't just come in and just put in a system and say, yeah, I just feel like putting a system. But then if you ask that person, why do you have that system? I just feel like it. That's a little bit foolish, especially nowadays where we tend to monitor every dollar, every peso that we spend. Okay, we can't just simply do things out of whim. Okay, or more so, you'd probably hear this from the undergraduate students. So when you ask them why did you create that system, well, they're normally stumped. They fall back to the general excuse that this is what our teacher told us to do. Okay, that may be true to some degree, but when you have or when you embark on doing an information system, you should be clear as to the objective or the problem that you want to address. Okay, so solving the problem. Okay, now the system can actually be the solution itself. Okay, like for example, if you are trying to understand market demand, well, you can come up with a forecasting system. Okay, so the system itself becomes the solution to the problem that you want to address. But sometimes the system itself is not really the solution itself, but it's part of the solution. Okay, because the actual solution to the problem is done somewhere else. Okay, and remember, these are information systems. Sometimes on their own, if the issue is ignorance or you just like to know something, then an information system can help you do that. But on its own, if you'd like, let's say, the case of manufacturing, if you want to be able to speed up your process, your information system should be in tandem with your production line. So the information system is actually just part of the solution, okay, for a much larger system. Okay. Nevertheless, the information system that you do intend to implement should solve the problem either directly as a whole or indirectly or partially or as part of the overall solution. Okay. And how do you actually solve the problem? Well, there's this shorthand that we normally use. Okay, I use it personally. So it's either you build the solution, you buy the solution, or you borrow the solution. Now, borrowing the solution is like a hybrid or a middle ground between build and buy, right? So it's either you build a solution, okay, I know the problem, I know how to solve the problem, I build it. Okay. Another way would be, okay, I know the problem, I know that others have already done it and they've made it available for everyone's consumption, so I can buy that solution. Or I have a problem, somebody has done it in the past, but I may need to do a little bit more from that. Then I can just borrow the solution and tailor it for my purposes. Okay. So let's talk with build first. Okay. Now, in the literature, that's known as bespoke development. This is the typical approach. This is the traditional approach, as we would say, right? You have a business problem that you want to attack. Okay, let's just build a solution. That the challenge in the build option is that it can be expensive, it can take time, and the quality is not exactly what you'd expect it to be. Okay, and this is the general feedback in the history of systems development when you build things from scratch. Okay, that's the definition of bespoke development. Okay, you have a problem, you want to address the problem by building the solution from scratch, from nothing, really, basically. Uh, it has its own challenges, okay, and those challenges more often than not tend to hover the historical lore of system development. In fact, for those of you who've been in the industry for such a long time, you'd probably be wary of doing a large build development, unless you're really, really, really sure that that's the only way to go about it, right? But back in the old days, especially in the 70s, 80s, or 90s, uh, you don't have the luxury of buying something that is available. Okay, so you have to build things from scratch. Okay, and this is a typical approach when you build something. So this is your system development life cycle. So SDLC, for those of you who are familiar with it. It can also mean software development life cycle. Okay? But if you've noticed that the steps are generally the same for in all cases, you'll probably have different terms or different names or labels for each step. You can probably have more, you can have fewer steps. I mean, but the whole idea is the same. Okay, so you start off with something, you analyze it, okay, you check if it's feasible, you come up with a design, building it, implementing, and then once you're done implementing, you maintain it. And if the system no longer serves its purpose, you can actually sunset the system. Okay, but in different types of books, they probably have different terms, but it follows the same flow. That's how the usual build cycle works. Okay. Well, it's a cycle in the sense that after you sunset the system, you'd probably start off doing another system, okay, that would replace the old system. But it's rarely linear or sequential. Normally, if you need to replace an existing system, you would have probably done the initiation way before you're actually going to sunset or kill the system, right? Now, building is not always the best. So these are the typical issues that have been noticed over the years when you follow the build approach. Okay, so and for those of us in the industry, we see this, right? We resonate with what's listed here. So, for example, there's a gap of understanding between the users and developers. You'd always have that ping pong match. If you're in the side of the developer and you're talking with a user, sometimes you always have that challenge wherein the user doesn't seem to understand what we're trying to do here. We're trying to do good things here, but they don't seem to understand. The users, on the other hand, they'll tell themselves, these developers, they don't know what we're talking about. They don't know that this is what should be done. Okay, this is what's best for us. Okay, I mean, we're the clients here. Why don't you listen to us? Right? So there's always that gap of understanding. Okay, another observed issue would be the tendency of developers to isolate themselves from users. Now this is just an observation, but if you were to try to find out why that is so, why is there a tendency? Okay, some people would say it can be behavioral. Back in the old days, the developers tend to be stereotyped as geeks, okay, or antisocial, maybe. Okay, so okay, I mean, if that's true, behaviorally, you would expect them to really isolate themselves from everybody else, okay, not just from users. But that's what's also observed, okay? But more often than not, the tendency of developers to isolate themselves from users stem from the fact that the developers don't really understand the business of the users, right? They don't know how these things work. Okay? This is the typical shorthand, when people say, I'm just a coder, I'm just a programmer. I don't know the business that well. I'm not a businessman. So we tend to use that as an excuse for ourselves, okay, for the developers, that we don't really need to learn what the users are doing. Okay, well, now we know that. Okay, if you do that, you actually do not have a perfect understanding of what is really needed by the users. Okay, quality is measured by the closeness of product to specification. Okay, and for those of you who've done architecture, uh, you would know that sometimes it is not what you want, but what you need, right? So in this case, this point tells us that uh, a system is good if it is close to what I want, okay? But it's not probably what you need at that moment. Okay? You can have all the bells and whistles, but it still won't achieve the business objectives that your company would have. Then the quality is yeah, it may score very high in that criteria if you look at the specification, but it's probably not what you need at that moment. The next point, long development times. That is okay. That's quite observed. Okay, and more often than not, the long development times really stem from various reasons, such as scope creep. Initially, you had an understanding of what needs to be developed. Then, as time goes by, okay, you realize that that's not exactly what's needed. Okay, so you change a little bit, you extend, you go ahead with changes. Okay, so that's what happens. Okay, and you're farther away from the finish line. So long development times. Okay, business needs change during the development process. Okay, especially for long-term projects. And it's not the fault also of the user. It's also not the fault of the developers, or so. But if there were changes, let's say in management, okay, you had a new leader, a new management team, then the business would change, okay, in terms of their objectives. And what was established before, maybe 6 months ago, may not be true now, especially if you're working in an industry that is hyper, okay, that is very quick. The business needs do change rapidly. So how do you address that? And back in the old days, if you're not really that robust and agile, uh, you realize that you've practically wasted months worth of progress. Okay, even if you're very very rigid or meticulous from a project management point of view, but because the business needs changed, it has become a moot point. Okay, and well, last point here is that what observers get isn't necessarily what they want. Okay, and again, I think a lot of it also stems from the fact that users and developers don't really have a perfect communication line, so there tends to be some confusion along the way. Okay? And if you think about it, you're actually contributing to the problem more than you're solving it, right? So if you're not really able to solve the problem, then you've actually added to the problem, right? Now, but it can be improved. So these are the examples of methodologies that have been developed over the years. You probably have heard of them. Some of you might be actually be doing them. Okay, so I'm not going to go in depth as to what each one would entail. Uh, the reading materials in Canvas would provide you with some more detail here, but I'm just listing them down so that just to give you the point that there are many ways of improving the build approach. So the build approach is not necessarily a foregone conclusion, like it's the worst thing that you can think of. Okay, build can still be a feasible option under various conditions, right? And if you do intend to actually go ahead with a build approach, there are many ways on how to ensure that your build option would lead you to a higher rate of success. Okay. And over the years, this has been the challenge of software engineering scholars, right? They try to find ways on how to improve system development through the application of improved methodologies. Okay, so you have RAD. For those of you who've encountered it, it's a early 2000s model, if I'm not mistaken. I encountered it myself back in the old days. Spiral model. This is like an improvement of your waterfall. If you guys are familiar with the waterfall model, so the spiral model is one improvement of that. Okay, and more recently, agile has been in the forefront. Okay, so but when you talk about agile, there are many agile methods. Okay, so if you're familiar with Scrum, Scrum is one agile way of doing things, but there are other methodologies there. Okay, and I'm sure in the future there will be other methodologies that will be designed or developed. Okay, I mean, there are other things also in the past that were trendy, but I don't think it survived mainstream consciousness. Things like extreme programming, that was also another methodology that was developed. Okay, but nevertheless, the whole point here is that if you do the build approach, it is something that can be used, something that can be considered, and there are many tools and methodologies that can help increase your chances of a successful project. Now, aside from build, now if you look back, okay, and see the ways of how we can solve a problem, build is just one of three approaches, right? So, as a matter of an important detour, whenever we ask students, particularly graduate students such as yourselves, that when you have a capstone project, the idea is that you're not limited to a build approach. That's just one out of three, right? You can also take a look another approach, which is buying. Okay, so a buy approach, or what we call off-the-shelf purchase. Okay, so in some literature we call them COTS, or commercial off-the-shelf. That is also another approach to solving the problem, because the problem that you may have encountered may not be a unique problem. Maybe it's a problem that everybody has experienced. So the software or the system that you will buy is actually the representation of the best practice for that particular problem. Okay, so when you go and do off the shelf purchase, what are the things that you consider? Well, one would be the software selection criteria. So these are the things. Okay, so if I'm not going to build and I decide to buy, so what's going to be my approach when I buy? Okay, so since you're not building anything, so that's everything there, right? So you as the IT professional, what will you be involved in? Well, you take a look at your selection criteria. Okay, I decided to buy. Okay, so what are the things that I should consider? Well, you take a look at the features. You take a look at the technology. By technology, we would mean is your technology expected to be growing, or is that going to be something like, okay, you don't expect any more improvements from that technology? Okay, you take a look also at software support and services. So this is on the side of the vendor. Okay, for you trying to or if you're going to buy it, will you just work it out on your own, or is it just, or do you have support? Okay, you have somebody to ask. You can take a look at costs. Okay, I mean, of course, the typical model for this would be through licensing, but there could be other cost models that would to be considered, and the level of customization that can be done when you buy. Okay, so yeah, it's off the shelf, it's standard. Okay, you're probably gonna have a vanilla version, but will my system allow for customization? For those once in a moment type of experiences, right? Typical customizations would be, can I put my own logo at the front page of the system? I mean, that's one way of doing it. Okay. Now, but other than that, okay, when you buy, you are now going to factor non-essential drivers. Not that you don't consider this in the build, but when you're doing the build option, you're actually spending more time on the technical aspects rather than in buy. But in buy, the technical aspects should have been covered already. Okay, so all you need to do is just taking a look at fit. So from a technical fit, okay, if that is a check to you, the question that will arise now when you do consider the buy approach is the non-essential side of it. Okay, for example, if you're dealing with a vendor, okay, is your vendor credible? Is your vendor the type who just wants to go out there and make money? Or is that vendor really like a partner to you? What about industries covered? Is your solution something that is specific to your industry, or is that something that cuts across various industries, right? The idea there is that if it cuts across many industries, then the vendor is incentivized to make sure that the solution, that the product that they offer is something that is sustainable. Okay, and there could be other drivers. Ease of use. Is it user friendly, as we say it? Is it flexible? Okay, will it cover all of the cases that I encounter? Is it versatile? Okay, is it responsive? Okay, and there could be other drivers. Okay, the point there is that when you look at buy, okay, after you've considered technical fit, then you consider something else. Okay? And more often than not, the decision calculus, if you may, is really geared towards the fact that you are going to spend more than what you normally spend off the bat when you build. But that's not necessarily true, right? Sometimes, in most cases, for projects, a build approach tends to be more costly in an aggregate sense compared to a buy, right? But I mean, it's a case to case basis. Sometimes the build approach can really bloat in terms of expenses if the build approach hasn't been properly been planned, or if the build approach hasn't been approached deliberately. Okay, or I mean, it's there could be other factors. I'm not saying that the build automatically is more expensive than the buy, but when you do buy, the cost factor is really something that is more up there, front and center. It's more conscious to you if you're doing a buy approach as opposed to the build. Okay, because in the build side of things, okay, your developers can probably be developing something else. Okay, not ideal, but that could be done. So in terms of the cost of the workforce, you can actually spread it across projects. Okay, and you tend to uh, juggle around in terms of the accounting side of things. But when you're in buy, that's pretty much cut and dry, right? If you spend for this product, you know how much you're really going to spend. So the consciousness, okay, is more geared towards cost when you're doing a buy approach. Now, lastly, if you don't want to build, if you don't want to buy, maybe you can borrow or lease. Okay, or it's so borrow is really more the middle ground between build and buy, right? And we call this the user developed applications. So applications that were not built by developers but were done by users. So the first thing that comes to mind is, how is that possible? How can users be the ones who will develop their applications or their solutions? Well, more often than not, okay, the users have to build on something that's already existing. So there is an existing platform, okay, and what the user will do is just build on it like Lego blocks, right? Uh, the original vendor, if you may, will have just the basic foundation ready. But once that's there, Okay, you're probably the vendor will just probably roll out some guidelines on how to build on top of it. The user would be left to their own devices to actually build whatever it is applicable for them. Now, some users can be considered like power users, where they tend to know more than your average user, but they're not developers. Okay, so in that sense, you can have platforms that are very robust. Okay? But the whole idea here is that user developed applications always start from somewhere. So in a way, it's not building from scratch, like the build approach or the bespoke development. But at the same time, it's not yet complete. Okay, that is typical, let's say, of a buy, when you do the buy approach, you have the complete package. Okay, so a borrow approach would be something like, okay, I have a platform. I let the user, turn on some switches, and it could be many switches. And then based on the switches, the entire solution will behave to a certain expectation. So the borrow approach uh, tends to be smaller compared to a bespoke development. So, and normally you see that in tools. So in tools type of systems, right? You don't see a borrow as much as let's say, full blown enterprise wide system. Okay. You can probably argue, what about like SAP or Oracle? Well, they're more buy than borrow, right? Of course, there are things that can be customized or can be configured, okay, but generally, the idea there is that that's more buy than borrow, but they're not build for sure. Uh, Another thing about borrow is that it's configurable. The initiative comes from the end user. Okay, it's not from the developer. Unlike when you're doing the build, the whole idea of how the system will work will have to come from the developer. Okay, but in this case, the user can be the ones to scale it up or scale it down, right? Depending on the behavior that was derived from the system. So it's configurable. So that's how borrow works. Now, overall, in a nutshell, when we look at the idea of acquiring a system, these are the three approaches. You have your build, you have your borrow, and your buy. So in bespoke development, the development can be in-house or it can be outsourced. Okay, and outsourced development was the trend back in the 2000s. Okay, but now in 2020, I don't know if that's still a very strong business model right now. In fact, a lot of the companies rather that I've seen, they tend to move also towards in-house. There's that idea of insourcing. Okay, but I don't know if that's going to be a permanent trend. Maybe they'll go back to outsourcing. When it comes to the build approach, off the shelf, it could be standard, your typical vanilla version, or it can be the one that is customizable or tailored to you, and you have your user developed in between. So with that, that pretty much ends the presentation on the acquisition of information systems. Are there any questions from you guys?
Sir, I have a question. For
Yes, yes,
example,
Michael.
you're building your own, let's say, e-commerce website. So, for
Mhm.
example, if it's when you build it, let's say it's either you build it yourself or get someone to build it. And
Mhm.
then if it's off the shelf, does it, for example, if I'm gonna use Shopify or some other platform, is that off the shelf or is that user developed?
Okay, that's a good question. Normally, the way to delineate the difference is how much user involvement would be in that case, right? If you're just simply going to register yourself in a system, like in the case of cloud computing, right? There's really not much that you do to customize the solution for yourself. So in that case, that's actually more of a buy approach rather than a borrow approach. But in certain cases, especially if you have users that are what I said earlier about power users, perhaps they have a cloud solution that they want to look into, and then they access certain features. Okay, they're given visibility to some APIs. Then that's probably a borrow approach more, because now you have the users capable of actually extending the use of your base or standard solution that's offered to everybody else. So the answer to that question is how much user involvement is involved, or is expected in the final outcome of your system. If it's high, then expect that to be more borrow. But if it's low, I mean, just the standard process that's to be expected with everyone, then that's practically a buy approach.
Okay, thank you, sir.
Okay, good question. Uh, Anybody else like to raise a question? Okay. Well, if there's none, okay. Well, we can actually end our session for today.